We'll go to the tabular method. So performing the convolution of discrete signals by using what is called as a tabular method. So this particular method, this particular method is direct implementation of the equation itself. For example, if I say the equation to perform the convolution y of n equal to x of n convolution h of n, the implementation should be in terms of this particular equation. Okay, so that is k equals to minus infinity to plus infinity. This is x of k into h of n minus k. All right, so we can see that there is a summation which takes care of the addition. Okay, I have to do the addition, or it is simply the accumulation. Okay, so first thing is accumulation, and the second part is nothing but it is a multiplication. I have to multiply x with, right, the h of n minus k. Okay, so I have to multiply, but before that I need to understand what is h of n minus k stands for, right? What exactly is this? I just have to understand. Okay, so let us check the meaning of that now. So when I say I'm doing the h of k into h of, because h of k will be directly available for us, right? But how to get the h of n minus k, right? For that, we need to understand the fundamental operations on any signal in the time domain. One of the operation we already have come across, and that is called as the shifting operation, correct? So in addition to the shifting operation, we can also have something like okay, so I'll just write one thing we already have written, so I don't write that. So the other operation is called as the time reversal. Time reversal. Okay, this is also called as a flipping. Okay, flipping of a signal. Right. So let us say I have a signal h of k, right? If I try to write h of k and I want to convert this into, right, I'll just write a flip, right? When the signal gets flipped, right, we can try to write that as h of minus k. Okay, so what is the meaning of that? Let's see with the help of an example. Okay, so let us consider a signal, right? Again, a discrete signal. I'm going to call this as h of k itself. All right, so this is the, say this is the y-axis. Okay, so this is h of k, right? Let me write some points. This is 0, this is 1, this is 2, 3, maybe I write -1, -2, etc. Okay, let me write the y values as well. So this is 1, 2, 3, 4. Okay, let's write the samples now, right? So samples could be something like, at 0, I assume that the signal's amplitude is 2. Okay, so this is the signal amplitude at 0. Similarly, the signal's amplitude at 1, I'm assuming that to be, say, 4. All right, and at 2, let us say its value is equal to 3. And let us assume that at 3, the signal's value is 2. Or let me make it 1 because 1 does not exist here. So let's say this is the value. Okay, at 3 it is 1. I'll also assume some values on the other side. Let me say at -1, the value is equal to, say, just 1, and at 2, let us assume it has a value equal to 4. Okay. All right. So this is pretty much clear what is the value of h of k, right? H of k versus, so when I write h of k, it means the horizontal axis is indicated by k. Okay, now my intention is to flip this signal. So flipping indicates, right? Let me write this. So I'll call this as the flipped signal. So let the y of k is equal to h of minus k, right? So in the sense, let me start. So the y of k indicate you can start substituting the values from minus infinity to plus infinity, because my axis is all the way from minus infinity to plus infinity, but it has values only for minus 2 to 3. So if you see here, this is minus 3, the value is 0, correct? Similarly, plus 4, it is 0. So signal does not exist outside this. So it is actually non-repeating signal or non-periodic function. Okay, right. So h of minus k, which I want to plot now, should look like this. This is nothing but it's a flipping of the given signal, right, about the vertical axis. So assume that you hold a mirror at the y-axis. Whatever that you see on the right side will come to the left. Whatever you see on the left will go to the right, and whatever is present at 0 will remain at 0. Okay, so let's try to plot that. Okay, so this is the k, and okay, this is the y-axis. And my intention is to plot h of minus k now. So let me mark the similar axis points. This is at -1, -2, maybe -3, +1, +2, +3, and so on. Okay, so 0, this is 1, 2, 3, -1, -2, -3. So you also have the values 1, 2, 3, 4. Right. So whatever is at 0 will remain 0, because if you put y of 0, this is h of minus 0, which is h of 0. There is no minus of 0. It's same as 0. So in my h of minus k plot, whatever was there at 0 will come. Okay. So whatever was there at 0 of my original signal will come at this position. So I know that this is at 0 I had 2. So the same thing will come back. Okay, it is still 0. But you see, at 1, y of 1 is h of minus 1. H of minus 1 is how much? Right? H of minus is, at minus 1, I had a value equal to plus 1. So that plus 1 is going to come over here. So you see, this is the mirror image. Whatever is on the left side will come to the right. Whatever is there on the right will go to the left. So at minus 2, I had a value plus 4. So that's going to be coming in my flipped signal at 2. So this is the value. That's 4. Okay. And at 3, I know it is 0. So minus 3, at 8, you had a 0 value which comes to the right. So it's the same. You don't have to write for 3, 4, 5, 6, 7 up to infinity. It's same. All 0. So I understand. So wherever you have the value, let it be visible on the side. So at plus 1, I have a value 4. So that comes now to this point. Okay, so you can see this is the graph. And similarly, at minus 2, I have 3. Okay, and at minus 3, I'm going to have a value that is equal to 1. So this is the other operation required in this, right? In this equation. Now let's come back and see what is this. So you can see my axis is k. So x of k as it is, no change. It's not going to shift. It's not going to be flipped. It's kept as it is. X of k is x of k in my equation. Okay. But h of k is there. You can see h of minus k, indicating that the h signal, whichever you consider, will get flipped in the process of convolution. And you see there is a n, right, which is indicating that it is going to get shifted as well because it is minus k plus n, right? So there is a shifting operation that is going to come into picture. Okay, so let me write what it is. So, right, this means flip, and right, I have to perform the shift that is applicable for h signal. So before you multiply that h with x, you have to flip h and shift. Then the resultant shift, whatever you have to multiply with x of k. Okay, so this is what is the mathematical process that we are going to follow in a method called as a tabular method. Okay, right, now let's directly go to a problem which uh, we are going to implement. We are going to solve by using the tabular method. Okay, right. So let us take a signal. Let x of n is equal to, this is 1, 0, minus 1, 2. Okay, and let's say the h of n equal to minus 1, minus 3, 4, minus 2, and 1. Okay, so this is the second signal. These are the two signals. Right. Anyway, I'll just copy the equation once again so that I can show you what is happening with respect to the table. All right. So let me write once again. So my result is y of n, which is nothing but convolution of x and h. So I'll directly write this equation. Summation k equals to minus infinity to plus infinity x of k into h of n minus k. Okay, so I will assume here this is the starting point, right? So both are going to have the indices 0 at these arrow marks. All right, so they are starting with 0. Let's go for a difficult problem at a later stage. All right, okay. Now, so this means, right, I have to start solving the problem by writing the required indices. So you can see that the smaller signal has index 0, 1, 2, 3. Okay, and the larger signal in terms of length, okay, the h of n is the larger signal. This has length 5 starting from 0 till 4. Okay, so ideal case is that you start from, right, whatever, if the larger index is 4, you start from minus 4. That's what is the ideal value that we are going to write. So let us try to write like this. So say k, I'll start with the indexing, that is a k. I'm writing a table. This is the first row of my table. So k, right, I want it to start from minus 4 because the larger length is going till 4. The index is 4. Okay, so minus 4, minus 3, minus 2, minus 1, 0, right till the largest on the positive side. Okay, so minus 4 I started. I'll go till plus 4. Okay, 0, 1, 2, 3, 4. Even if you add few more, doesn't matter. Okay, that's fine. So this will be my first row of the table. Let me mark it. So this is the row number 1. Okay, out of which my first, what I'm going to write, the second row of my table will be the signal which is not going to move. In the sense, if you look at the equation, x of k is there irrespective of the value of k, x of k as it is, but h will be shifted and flipped. So you see, you understand that h is the signal which is going to be moving. It's going to move. It will flip, right? There are many operations that are being carried out on the second signal. So you always will write the first signal which is fixed. So the next one, this is something like a row heading. It is x of k. Right. You just see where the signal starts. Only from there you write. It is starting at where? Starting at index 0. At index 0, its value is equal to plus 1. At index 2, it has a value 0. At index 3, it has a value -1. At index 2, it is -1. At index 3, it is equal to 2. Are you fine? All right. So this is what is the x of k. What I want to do, I just want to show you that this signal is going to be fixed. So for that reason, I'm simply going to put, right? I'm just going to highlight it like this. In the sense, it's never going to move from its location. So it also means that all the other values, right, of all the indices which you have marked, starting from k is -4 till -1 and +4 till infinity, its value will be 0. Are you okay with that? I'll just fill it just to make the table more clear. I don't want to have a blank space in my table. All right. Okay. Next, below this, you write your second function, right? That is h. So my second function using which I'm trying to do the this convolution, right? I just have to write the second function below this. All right. So let me just do that. So the second function is the h of k. Let me just. Okay, I wrote a x of k. Then below that, I'm going to write the h of k. Okay, h of k. Now you write the h of k as it is, starting from its position. So wherever is where it should be starting and what is the index, we know that. So in this case, it's starting at the same position, right? So this is -1, -3, 4, -2, and 1. So now you see, I'm not going to highlight it with any different color because this function is ultimately going to move all the way. It's going to get flipped and so there is no meaning in fixing this signal. So I'll not do anything, right? I'll just write the function as it is. Okay. So this is this row number 3 of my table. All right. Now what I do, uh, I look at my function, right? Y of n is equal to, right, x of k into h of n minus k. So I know that, right, when I put n equal to 0, let me write n equal to 0. I'm calculating the result. So n equal to 0 implies what happens to h? H becomes h of 0 minus k. H of 0 minus k is what? It is simply h of minus k, correct? I'm going to put n 0 here. When you make n 0, the n should become 0 here as well, isn't it? So that means, right, ultimately, the if you want to calculate y of 0, that is your answer, first sample of your answer, right? This has to be, right, x of k into h of minus k, multiply and take the sum. So before I want to multiply, I just have to take care that this h of n minus k, I have to perform where n equal to 0, that indicates it should be n equal to 0. It means h of minus k has to be plotted. So h of minus k I just wrote here. This is what I'm trying to uh, convert, right? H of k into h of minus k means what? You know that whatever is at 0 will be at 0, but whatever is at 1 will come to the -1. Okay, whatever is at 2 will come to -2, then this, then this. The zeros will go to the other side. Are you okay? Now you look at the equation. Now I actually got x of k there, which is fixed. I got h of minus k, that's also currently it is this. I just have to multiply where k is minus infinity to plus infinity. Just look at the multiplication. Now, starting from k is equal to minus infinity till plus infinity, multiply each and every element of x and h, right? Such a way that x of k is fixed, h you consider h of minus k. Right. That means, right, look at this. Look at the multiplication. Now I'm going to multiply. I'll change the color so that I can highlight h of x of minus 4 into h of minus 4. Sorry, x of minus 4 into this. X of this into this, X of this into this into this into this into this into this, and so on throughout from minus infinity to plus infinity. But I know that before minus 4, that is minus 5, minus 6, minus 7, etc., both the functions are 0. This functions does not exist, right? X of k does not exist, y of k also does not exist, which means the product is 0 starting from minus infinity till minus 5. Okay, minus 4 onwards, one of the signal might exist. So 0 into 1 is 0, 0 into minus 2, 0 into this, 0 into this, 1 into minus 1, this, and this. I can multiply. Some of the terms might be there. So whatever you have, you take the product and keep accumulating. That's what is the summation is all about. All right, now let me write those values because I didn't complete writing the h of minus k. So this is 0, 0, 0, 0. All right, so this is my next row, right? But before I fill the next few rows of the table, let me do the calculation, right? The calculation says you can, when n is equal to 0, I am going to get y of 0 because n is 0, right? So put that value over here, right? Make that as 0. That means your first sample is what you are getting in the answer, right? So it is nothing but simply one term, right? All others are 0. You can see here either you have zeros here or zeros here. So multiplication will definitely result in 0. Okay, so because of that reason, now let us try to multiply and write these values. So 1 into minus 1. So my answer y of 0 is simply minus 1. I got my first sample. Then make a change. Change n equals to how much? 1 now. So when n is 1, I'm writing h of 1 minus k. 1 minus k refers to all the signal in h of k, h of minus k getting shifted to right by 1 unit. So 1 comes here, minus 2 goes here, the 4 comes here, minus 3, everything gets shifted. That's all. Minus 1 comes here, the 0 goes to this side, 0 goes to this 0 goes here, and a new 0 enters into your this thing because at minus 5 you have 0. Okay, yes. Now you see, I just have to multiply to calculate y of 1, right? I just have to multiply these three. So this is minus 3 into 1 and minus 1 into 0. Other values will not come. Only multiplication that can happen is the 2, out of which one of them gives you 0. All other multiplications result in zeros. So this is the answer is minus 3 into plus 1 is minus 3. Are you okay? Then I'll repeat. So you see, every time you get a new sequence, this needs to be multiplied with x of k because now you see I have n is equal to 1. So x of k into h of 1 minus k, correct? Where is h of 1 minus k? That is this signal, right? Now multiply this signal with the x of k. X of k is this row. Okay, multiply term by term. So 0 into 0, 1 into 0 into this, 0 into this, 0 into this. Now you see 1 into minus 3 is what is this minus 3. Then you have to actually add all the product, but other terms are zeros. 0 into minus 1, etc. So because of that, now you got the answer is equal to minus 3. Okay, right? So that's how you calculate. Every time you shift the flipped sequence by 1 unit. Right. Now, until where you need to do this calculation, we'll come to know that. Okay. Soon we'll come to know that there is a stopping point. Right. Because the answer, otherwise you can actually put any value for n, right? N is equal to 1, 2, 3, 4, 5, 6, up to 10, 20, 50, 100, etc. You can put any value. But you will see that there is a stopping point that needs to be decided depending upon the given problem. All right. Okay. So let's look at that now. So how to write this. So I got y of 1. Let me go to the next row. So when I go to the next row, I'm expecting that I will put, okay, say this is the next row. All right, now what I do, I make n equal to say 2. So that means h of 2 minus k. What you have to do, keep shifting the signal to right by 1 into. One more 0 comes, this 0 goes here, 1 comes here, minus 2 goes here, the 4 enters here, all right, minus 3 here, minus 1, the 0 and a 0. This 0 actually goes out, which we are not plotting since we are not showing 5. Okay, so because of that reason, you don't have to worry what goes out. Okay, all right. So this is what is the table, right? So I just now I can calculate using this particular row of the table. I can calculate y of 2 because n is equal to 2. You can see n equal to 2 written over here, right? So using that, I can actually determine which sample I'm finding out. Okay, now y of 2 is equal to only this product 4 into 1, 0 into minus 3, minus 1 into minus 1. So what is the answer? 4 into 1, 4 plus 1. So the answer I can write now is y of 2, that is equal to 5. Right, let's proceed further. So now I'm trying to write the value at n equal to 3. Right, as we already have done, right? When I try to represent the y of 3 minus k, right, n will becoming 3. So this is h of 3 minus k. That means 0, 0, 0. This 1 comes here, minus 2 goes here, 4 comes here, minus 3, minus 1, 0. So this is y of 3. Right. Just calculate this by looking at the red colored. That's why if you understand now why I actually put a red color, because only this region is considered, right, for a product. I don't have to consider any other. So it's 1 into minus 2, 0 into 4, minus 1 into minus 3, and 2 into minus 1. Only take care of this product. So what's the answer now? The final answer is equal to minus 1. Okay, so let us write that. So y of 3 becomes equal to minus 1. Okay, all right. Next, you can repeat the same process. All right, so now I perform the next operation by making n equal to 4, and I'm writing h of 4 minus k, right? So this will be adding zeros, 0, this 0 comes here, 1, minus 2, 4, minus 3, minus 1. So I'm calculating now y of 4. How much? What is the answer? Calculate and tell me that. Okay, so it's minus 9. Then let's move further. So next I have to do the n value equals to how much? N equal to 5. Okay, make n equal to 5. So h of 5 minus k is the name of the row, right? Keep shifting. So 0, 0, 0, 0, 0. This 1 comes here, minus 2 goes here, 4 comes here, and minus 3 goes here. So the minus 1 actually goes out, right? You don't have to worry because you are multiplying that with the 0 in this particular step. So what is y of 5? Okay, so this value comes to be equal to 10. Right, next I'll write n equal to 6. So I'm actually writing 6 minus k. So 0, 0, 0, 0, 0, 0. This 1 comes here, minus 2 comes here, 4 goes here, minus 3 goes out. So I'm supposed to calculate the y of 6. Minus 5. Okay. All right. Next, let's proceed further. So this is n equal to 7. I'm giving the row heading as 7 minus k of the function h. So add zeros, 0, 0, 0, 0, 0, 0. This 0 comes here, 1 comes here, and the -2 goes out. Okay, so I'm writing y of 7. All right, so this is 1 into 2, so 2. Now you see what happens if I going to give another shift. What is the answer? In the sense, perform n equal to 8, h of 8 minus k, right? Will which makes the multiplication result as 0, right? Are you okay with that? Because you see all zeros will come here. 0, 0, 0. This 0 shifts here. All here are zeros on this side, which means the product is 0. Right. After this, you keep giving any number of shifts, like make n equal to 9, 10, 11, 12, 100, 2000, 20,000, whatever. Right. You see that it is going to be 0 here onwards. So you don't do any multiplication after this, you stop. So let me show you the complete this thing for your reference, right? You can, right? Just look at this. This is what is the table overall table, which gives you an idea that how the how the convolution has been performed. Okay, it gives you a very clear idea. Let me just go back so that you can even see the signal, the equation y of n, and right the function. Okay, so let me highlight with a different color what exactly we are looking at. We are only considering the values within these two lines. If you are able to observe carefully, so we actually did the multiplication between only these two. The rest of the table is just for our understanding. Otherwise, this is what is important for. That's why, instead of writing the two lines initially, I just had highlighted this region. So we just have to perform like this and do the calculation. And now I can write the final answer, right? What is the y? So let's write that now. So just look at this. This is how I write the answer. Therefore, the final answer, y of n equals to -1, -3, 5, -1, -9, 10, -5, and 2. Okay, wherever it is index 0, that's where I need to put an arrow mark even in my answer, indicating that this is the 0th index. That is important. Okay, right. So this is the procedure of performing the convolution using this particular method. Okay, method is referred to as the tabular method. All right. So now I'll give you a problem to solve. Right. Try to find its solution using the same method. X of n is equal to, this is 0.5 minus 1.25. This is 2.5 minus 3.75 and 1.5. This is x of n. Write h of n like this. H of n is equal to, this is minus 1.8. So again, this is the starting point. 2.15, 8.96, minus 7.67. Okay, so perform the convolution of these two signals, right, or functions by using the tabular method.